Once again to all of our great presenters, and my mind is spinning a little bit right now. Perhaps you have some questions or would like to have some elaboration on any of the points that have been brought up today, so we have a little time left for questions. And I say we have several. So, gentlemen, if you'll come forward, maybe you can sit down here and address.
No, you can't take anything. Can't take anything at face value. You're absolutely right. So that you raised a number of points. Let me say very quickly, the pharmaceuticals industry. Think what you like of them, but they've really led the way on trying to get some metrics on the reproducibility of research, and the news is not good. This should not surprise anybody. In a system in which thousands of things interact, experimental control is enormously difficult. So the inability to replicate an experiment from one lab to another is not a surprise. That said, you do want high quality knowledge, and you do want to test interesting hypotheses. And so the end of the pipeline that I started talking about is robots that actually test the hypotheses in vitro. And we have a group at the University of Manchester. We have collaboration with the Frederick National Lab for Cancer Research to do exactly that. I mean, if something looks worth testing, it's now possible to test it robotically. You guys
have I think one of the interesting things is whether or not, irrespective of the reproducibility of those findings, whether they provide any extra information that we can use. So I think, I think any content that's produced under attempting to do these experiments is useful. I also think, in terms of your reproducibility initiative, I think the idea of having more robotic interventions, or at least the ability to go to places that can reproduce those, a la science exchange, or having something that's more of a service model for pulling experiments, is quite interesting in and of itself.
Can I draw attention to a slightly different aspect of it? Yes, of course, stuff needs to be replicable and all that. But one of the things that we are still struggling with at this moment is that the information that exists, that we already have, is not necessarily widely enough accessible and available to people who do these kinds of analyses. And I'd like to make the case that really we ought to make the published results of scientific experiments far more easily and far more widely and far more conveniently available to those who can then subsequently do all the things that we've just talked about.
Other questions? I have some other productivity scores about the growth and the tracking of growth, and they are the same. I can get you the graphs. I don't have them off the top of my head, but it's the same idea. We're getting 3% growth in researchers, and we're getting 3% growth in submissions of papers. So I have some stats for you, but I can get them afterwards. Yeah.
Well, we have to be careful. Most of the bad press about reproducibility lately has been about the ability to reproduce the analysis of the data, not the experiment itself. It's very, very expensive to do experiments, and so there's relatively little going on in people sort of trying to quantify how hard it is to replicate the experiment. But still, the news is not good. Which brings me to a kind of content that I think we're going to see people publishing increasingly. Right now, people publish words and tables and data, but if you're interested in understanding complicated systems, what you do in your lab is you build simulations. And I'm waiting for publishers to realize that what often gets circulated as knowledge is what we might call executable knowledge in the form of simulations. So, yes, we always want to go back to the lab to make sure that the underlying assumptions of the simulations are right. But yes, we also want to circulate not what people say, but a mechanism that actually does something. And you can run the mechanism yourself in different conditions and see whether you get the same results. The reason this is important is that, at least in biochemistry, people can be wrong about the precise details of, for example, the rate of a biochemical reaction, but right about the qualitative behavior of the whole system. So a lot of failure to reproduce is at a level of detail that probably doesn't matter if you're looking at the whole system and how the whole system operates in a qualitative way. The only way to actually do that is to ship around not papers that describe the conditions under which I ran an experiment, but the simulation of the complicated system that I think I'm commenting on. And once publishers start doing that, I think the reproducibility issue will sort of wane. It'll become less of a problem.
I don't want to gainsay any of that. I fully agree with it. But there is also an element in the kind of sloppy way we do it now. If I look at the materials and methods sections of many papers, they're extraordinarily thin and extraordinarily unprecise. And I think just doing that better. For some reason, these sections are squeezed, and I think they're the most important sections of the entire paper in many cases. And yet there seems to be a culture of keeping that a very summary kind of approach to the materials used, the methods used, the not spelled out in sufficient detail. And I think that a fair number of failures to replicate and reproduce is due to the fact that you really don't have all the details necessary to do it. And I think that is something we can change tomorrow by insisting that authors describe these things very, very well and in very great detail. And publishers here, I think, have a role to play in making that happen.
So I think, just one thing to say there is that I think there is a move to publish both software or executable models. So there's numbers of people doing, I know we publish something called original software publications. We also publish something, a new journal, Method X, open access journal, just for publishing methods, and that actually seems to have taken off. People are looking for places where they want to publish their methods, and I think that's a great outlet for those kinds of things in any publisher. It's good.
So, sorry. Another thing that I think is really important about, as you say, publishers should be explaining things better. But maybe what we also need from you is for you to tell us what it is that you're looking for. We need consistent terminology and ways to refer to things. But it would be great if we had a consistent set of standards that people use to evaluate an article. Certainly the kind of experiment that it was, the number of participants. But if we're going to have a machine read the article and have to evaluate it, we might need you to tell us exactly what elements should be in the article. And I would also like to say, we have ourselves on the back here, that this validating people is a copy editing still, even in this world where we are using much.
So I would love to see copy editors writ large. So I would love to see people. So one thing about reproducibility that people don't understand is that it takes a lot of effort to document. So I actually looked at this. If you want to get a software code documenter, there's a German one, a guy I looked up for top result in Google. It's 50 euros every 2 hours, and it takes him about so 25 euros an hour. No, it's 50 euros an hour, and it takes him about 3 hours to document a new piece of code, and that's on his kind of price list. That's expensive. And by the way, I have PhD students still, and if I want them to document their code, they look at me like I'm insane, right? Even though they complain when they're reproducing somebody else's set of code. Okay, so I think there's a service that is very interesting that nobody is providing, is assisted documentation, helping people write better code, or at least managing the production of saying, okay, this is enough such that, and will help you get your code to a place that is reasonable. So code copy editing.
But can I just comment on this as well? Because what Paul Cohen was saying is that if you have loads and loads of genes or loads and loads of proteins, how many different names do we have for all those entities? It's amazing. It's sometimes you have a protein that's described in 3 or 4 letters, and then you find for that same 3 or 4 letters you have 84 different meanings, or you have for one protein 10 different names. So one of the things that copy editing could do is disambiguate these things, make sure that it is kind of standardized. It's using fat chance, yeah, I know, fat chance, but using proper ontologies to at least identify where it comes from would already be a great help. And one of the things that I mentioned about the materials and methods is that, for instance, antibodies are often not identified properly at all. Where they come from, which batch number, and so on, that would help immediately. And I think publishers should insist on that kind of thing. Absolutely, but it subsequently it needs to be used very widely by all publishers publishing in those areas. This is really the case I'm making.
Exactly what they want to say. And the way they communicate it is by prose, putting in text in English or another language. And we get the problems that you were saying, that it's impossible, next to impossible for a computer to work out what they were trying to say with certainty. I'm wondering if there is so what we need to do is to make that document as structured as possible. Now right now we have ways of putting taxonomies in later on, but I'm wondering if instead of writing a sentence, the system would assist me and guess what I'm trying to say and put it in a definitive way. For example, I don't know, aspirin cures headache.
I think the machines should do the work. I don't think people should do the work. Moreover, although I cautioned that machine reading is not great right now, it's serviceable and it's getting greater. It's getting better. I also strongly disagree with the idea that we should try to come up with a unique identifier for each and every entity, partly because it's not workable. The same entity may be referred to in different ways by different communities of practice. You can't tell them, you must talk about it the way the chemists talk about it. That's just unworkable. And in practice, a biologist reading the text doesn't have any trouble figuring out what this crazy entity is. So we need machines to be more like that, not make humans do things that they don't do naturally.
Yeah, I think that's the lesson is key, that machines are getting really good. I mean, I think they're not there yet, but for many tasks, they're really good. And we have a long history in like AI of trying to get people to give us knowledge in a structured form, and you just can't. The social effort to do that is unworkable, and we just want people to give us any knowledge, and the machines will be smart enough to figure it out. We can already reproduce databases. We can already have very interesting applications independent of, what they're trying to do at DARPA is build extremely complicated causal models, but just up to the point of giving me a great structured database or letting me do, spoken word queries, natural form queries. We're there. We have it. You guys use it. I mean, Siri is not that great. It makes mistakes, but it's pretty good, right?
I got to say, I have a lot of sympathy for what you're suggesting. I saw coming out of SRI, there's a formal language called pathway logic. It's a beautifully worked out logic for describing molecular signaling pathways. And the first time I saw it, I thought, well, screw it. Why is anybody writing English? This stuff is really great. And so I said to the biologists there, why don't you just write this stuff in your papers instead? And they rolled their eyes. I agree with you, right? It's a rational point of view. I just don't think it's going to work.
But one of the things that maybe in that regard is the history of scientific publication and scientific writing. It used to be so that people really told a story, and then in that story they buried all manner of data and so on. And that is still the style, even though the amount of material and the methods we use to publish are not really suitable for that anymore. What you mentioned is that we refer to something. Well, we mention a protein and then we say this protein and so on. That we should just repeat then what it is about, but that doesn't look good. That sounds a bit awkward. On the other hand, that would really, remove many more ambiguities. But we are still in this, we call it literature for some reason. It's not really literature. It's reporting what's happened or what we have observed, and we and even things like plagiarism come into it. Yes, you should be able to use exactly the same phrases as someone else because it's much clearer. And yet we don't do that because we think, well, then we're really plagiarizing someone else. No, you're not. We're being clear.
If you want to make the co-reference problem go away, you must promise to never use a pronoun. Right? Because the moment you say it or that or one,
Absolutely.
it's not.
Do we have time for one last one, or are we?
Sure, one last one.